All right. Hello, everybody. Hope everyone is doing well and staying sane as they quarantine during this really unprecedented time. I'm sure you guys miss seeing your ACE mentors in person, but I hope that you guys can learn something today about sustainability. We're going to look at the built environment, buildings, and structures from a sustainability perspective. My name is Emily McDuff, and I'm an energy engineer with AECOM out of the Washington, D.C. area. And this is both the area and field that I work in, but it's also what I'm most passionate about. Building our environment in a way that helps the natural environment and doesn't deplete the world's resources. So we're going to start out by looking at sustainability from a day-to-day personal standpoint. So think of ways that you save energy and water in your everyday lives. Think about when you wake up in the morning, when you go to brush your teeth, how you get to school or work. And then finally, at the end of the day, when you cook dinner, what do you do with your leftover food? How do you package those leftovers? So these are some simple examples of ways to incorporate sustainability into your everyday lives. You can turn off the water while you brush your teeth and save water that way. You can turn off the lights when you leave a room, even when you just go down to dinner and then come back up to finish your homework. If you did that every day over 365 days, that saves a lot of kilowatt hours of electricity. As you go to school or to work or to hang out with friends, walking, biking, carpooling, or taking public transportation like the bus or the metro or the subway if you're in New York City, these are all ways to live in a more sustainable manner. So we're going to start off with some terminology and some vocab before we dive into a deeper discussion. But first off, take a look at these words on the screen and think about if you know any definitions or if you've heard of any of these before. So we'll start with sustainability. This just means using resources at a rate that doesn't deplete those resources. So think about fossil fuels or the amount of wood that we have in the world. And a good day-to-day example would be, think about your hot water heater in your home. If you have a brother or sister like I do, when I was growing up, my mom would get so mad if I took like a 30 or 40 minute long shower because I'd use up all the hot water, and then the rest of the family would have to take cold showers. So if you apply that example in a larger setting, the amount of fossil fuels that we have in this world, it's a finite amount, and we've become greatly dependent on them over the last 100 years, but eventually they're going to run out and future generations won't have them to use. And in addition, they're emitting a lot of carbon and pretty nasty pollutants into the air that's causing climate change. And so when we think about sustainability, it's all about resources and how to conserve them or change the resources that we're using so that the environment's in a better spot for future generations. Net zero energy. So this means over the course of a year, producing the same amount of energy that you consume. So a lot of times in a building setting, this is having solar panels or small scale wind turbines or something like that on your site to produce the same amount of electricity that you consume from the grid. And then net zero carbon, this means sequestering or pulling out of the atmosphere the same amount of carbon that you emit into the atmosphere. And we're humans. I mean, we breathe carbon dioxide, but then we also drive vehicles that use fossil fuels. Our power plants, I think it's over 75% of our power plants that burn fossil fuels. So we have a lot of progress to go. And it all goes back to this balancing equation. So using the amount that you consume or producing the amount that you use or consume yourself. Okay, resilience, the next topic. So this is the ability to recover quickly or smoothly from a failure or disaster, like an electrical outage. Eco-friendly, this is more of a broader term. So this could be eco-friendly materials for your building. So using local materials or materials that don't produce pollutants into the atmosphere. But it can also mean things like when you go on a hike, leaving no trace, leaving no trash wrappers on the trail as you go. Okay, our last vocab term is LEED. You've probably heard about this or maybe seen plaques in front of buildings. This is an organization called Leadership in Energy and Environmental Design, and they help come up with building codes and certify buildings that are sustainable or that consume less energy or water, and also are designed in a way to help the environment around them. We're first going to look at sustainable design from a passive design perspective. So this is more on the architectural side. And here are some ways that you can incorporate sustainability into building design from that passive perspective. So by passive, I mean using the environment that the building or the site is already located in to design it in a way that's more sustainable. So for example, orientation. So if you are a house in North America, if you're facing the south, you're going to get the most solar gain. In other words, the sun is going to be hitting your house for the majority of the day. And so if you're in a place kind of further north, like say Maine, you might want to orient your building towards the south so that you have that solar heat gain coming in naturally and you don't have to use your heater as much. But if you're in a place like Florida, if your building is facing the sun all day long, your house is going to be so hot and you're going to have to use your air conditioning system and a lot more energy to cool it. So you can orient and design your building in a way that takes advantage of the way that the environment is set up where your site is. Window to wall ratio. This kind of goes back to the same concept. So if you're in a really hot place, if you have an all glass building, you're just going to be sweltering hot all day long, and you're going to have to run your AC system more than you normally would in other climates. So you may want to have more windows than walls and use window materials that kind of are reflective or don't have as much solar gain. But if you're in a place where you do want that solar gain, you could have more windows. Natural ventilation. So a lot of AC systems in the shoulder seasons, which are spring and fall, will use natural outside air. Since the temperature is so close to what you need at 72 degrees inside, rather than starting from scratch for the whole heating, ventilating, and air conditioning system, you can kind of use that outside air, and you don't have to do as much conditioning if you have the proper equipment, because your air is almost at the temperature that you need. You just need to filter out some pollutant. The envelope of the building, think of it as the skin of the building. So the walls, the windows, anything on the exterior, the roof as well. And by putting in sunshades and materials that are beneficial to use the sun as it naturally hits the building, but also make sense of that orientation. That's a way to design the building envelope in a way that is sustainable for the environment. Okay, now bioretention and landscaping. If you went to a parking lot 15, 20 years ago, so when I was a little kid, there were not many bioretention landscaping areas in parking lots. It was just a full concrete block, and whenever water hit, it would pool wherever there were potholes, and it just really messed up the watershed. And so more recently, areas are designing parking lots and paved areas so that there are rain gardens or bioretention areas to kind of capture that rainwater and then also serve as a natural filtration system as the water's going through those natural areas. So this is a really big one because think about it. If all of the water that used to hit on that spot where there's a parking lot used to be captured by the rain and retained on site. Now, if it's all paved, where's that water going to go? It could run to a building and flood a building. You could really mess up your watershed. So think about like the water and cloud cycle. If water typically pulls from the same area and then rains that water back to the site, if you put in paved areas that kind of mess with where the water is landing, that could have a large impact in terms of drought down the road. So it's important to try to retain the amount of water that hits your site naturally so that it stays in that same cycle. Okay, this is where I'm more comfortable. I'm actually an engineer, so the architects I get to work with every now and then, which is great. But I work more on the active design side in terms of sustainability. So this is what I'm more familiar in. Here are all ways to incorporate engineering into your design to enhance sustainability of your built environment. So systems control or building automation system, you can program your whole house. I mean, think of like a Nest at a small residential level, but you can program your house so that you have setbacks when you leave during the day. You don't need to have the same level of heating or cooling if you're not in your house. So when it's winter, you could make it so that it's a lot colder when you leave your home on vacation or when you leave for school or work, so that you're not over conditioning a space that's not occupied. LED lighting, so this is light emitting diode lighting. It uses 75% less energy than your typical incandescent lights that you would think about, like your average Edison light bulbs almost. So these are great for cutting the amount of electricity that you're consuming. Also daylighting, you can add sensors to your lights so that when the sun is up and you're getting natural light and you really don't need the lamps or overhead lights in your space, it'll cut electricity to those lights so that you save and conserve energy. High efficiency HVAC, so this kind of goes back into using your outside air when the temperature is right, or using variable air volume systems instead of constant air volume systems, so that as your occupancy changes in buildings, your heating, ventilation, and air conditioning system adjust with that. Renewable energy, this is awesome. I mean, this is what we really need to get to. If we really want to save our climate, we really have to just get rid of fossil fuel electricity and power generation and just switch to renewables and battery storage. And batteries are key because think about it, your solar panels can only pull in energy when the sun is out. But if you have a battery system tied to that, any excess electricity that your building or system doesn't use, but that is pulled in by those solar panels, can be sent to your battery system. And so that when it's dark out and your solar panels aren't producing any electricity, you can just pull from your battery system, which is really cool. Okay, and then lastly, and this is more cutting edge, newer technology, but carbon capture and sequestration. And it's becoming more and more important, especially as our climate continues to change. But a simple version of carbon capture would be planting a tree. Through photosynthesis, trees naturally pull in carbon and then sequester them in their roots and in the soil. A more fancy way is that you could put in machines kind of like that photo to the right that draws in air from the atmosphere, filters out carbon and stores it, and then emits the clean air on the back end. So that's active design. What are utilities? First off, I am curious if you know what the word means. But second of all, if you know what utilities are, and a hint is to think back to Monopoly, think of what types of utilities there are. So I'll give you a second to think. Okay. These are the main ones. So electricity, natural gas, water, propane, and diesel gas. So the utility really just means a service to power. So it could be to power lights, it could be to power your natural gas fired boiler to heat your home. But these are all the services we pay for, I mean, with the exception of like Wi-Fi. These are mainly just for energizing your building. We're going to look at the basics of electricity because this is such a big piece of the pie when it comes to utilities and energy consumption. So I'm curious if you've ever heard of the word watt, kilowatt, or kilowatt hour. We're going to go through those definitions. So a watt is a unit of energy. It equals 1 joule per second. A kilowatt is the rate at which electricity consumed. So it's 1,000 joules per second. And we'll go over some examples in a little bit if this seems a little confusing. A kilowatt hour is your amount of electricity consumed over time. So it's the rate of electricity consumption times the amount of time that you're consuming that electricity. So a good way to think about electricity is to think about a car. The rate at which you drive your car, that's your miles per hour. So if you're going 60 miles per hour, you're going pretty quickly. If you're going 30 miles per hour, That's more in like your neighborhood locations. But over the course of however much time you're driving that car, those are the amount of miles that you're going to drive. So 60 miles per hour times 1 hour, you have driven 60 miles. Same thing is true for electricity. This is kind of how electricity and utility companies look at the amount of electricity you're drawing from the grid and then the amount of electricity that you're using in your homes. And this is how electricity is billed. That's why it's important. So here's an example electricity bill. We don't need to go into the weeds, but just recognize that we have kilowatt charges. So that is the rate at which you're consuming energy. Another word for it is your load. So if you have a big draw from the power grid, say your whole family is trying to charge their cell phones at the same exact time and be on their computer, and you have the refrigerator plugged in, your load or the rate at which you're consuming electricity is going to go sky high, and you're going to be charged a lot more for that on your electricity bill. Now your kilowatt hour, that's your consumption. So that's over the course of a day or over the course of an hour. How much electricity are you actually using? And both of these, as you see, there's some kilowatt hour rates, there's some kilowatt rates, and all those add up to a total kilowatt hour rate. So that's your consumption, and then a kilowatt rate, which is your demand. So how much are you asking for from the grid? What rate are you asking for electricity for? Okay, so we just went over sustainability design from an architectural standpoint, from an engineering standpoint. We went over electricity rates and metrics and electricity bill. The last thing we're going to do before we wrap up is we're going to design a solar photovoltaic system. And it might sound like a huge undertaking. We're going to use a really cool NREL site to do it. And I'll just kind of walk you through how all these concepts kind of tie in. So if we think back to ways to increase the sustainability of your sites. Actually, let me pull up the slide again. So this was one of the ways to actively engineer your building to be more sustainable. So renewable energy. And solar is awesome because you can just put it on your roof, you can put it on top of a parking lot garage, and it can just be kind of there. And whenever the sun's out, it's pulling in electricity. So this is the PV watts calculator, again, watts, you'll recognize that word, that NREL put together. And this is a government research agency that looks into these types of things for renewable energy. So this is the PV watts calculator. You put in your home address or your zip code. So I'm going to put in the zip code for Washington, D.C., because that's where I live. All right, so it's pulling up weather data for the area, and it's pulling up the utility rates for where I live in Washington, D.C., which is really cool. And it's all in this calculator. And something to remember when you're designing a solar PV system or a solar system, which kind of makes me laugh. It makes it sound like you're designing the Milky Way or something. But when you're designing a solar system, you need to think about, okay, where is sun hitting my site? Are we on a site that gets a lot of sun? Are there a lot of trees around that would block the solar panels from pulling in that sun and converting it to electricity? Things like that. So that is what this calculator is looking at. So we put in our zip code, we're in the US, we have our solar data, which is going to help us determine how much electricity panels in Washington, D.C. would actually produce. Now we're going to go to our system info. So a standard average size of a solar PV system for a residential building, so think about like a home, is about 5 kilowatts. And that's in DC. So this is direct current. And then our solar system is going to convert that direct current sun energy into alternating current electricity that can run through the grid and run through the electrical wires in our home. We're going to do a standard module. These are kind of systems. So this is how your panels are aligned. System losses. So these are the electrical losses in the system. And this is kind of natural. It's actually interesting. So like a fossil fuel power plant has system losses of like 40 or 50%. So this is actually pretty good. This is your tilt. So what's the tilt of your panels? So the azimuth, this is the degree at which sun is hitting your panels. And this is pretty cool. It automatically pulled up the residential electricity rate per kilowatt hour that's charged in DC. All right, so now we're going to go to the results of our system design. Awesome. Okay, so if we were to put in a solar system, a solar array on top of my house in DC, I would save almost 7,000 kilowatt hours of electricity every year. And I would, the value of that, so I would save about $700, $800 in electricity bills every year just by having a solar array system on the top of my house. So now what I want to do is see how much it costs to put in that system on top of my roof, if I were to put in a system, and how many years it would take to pay that off with the amount of savings in electricity that this system is producing. So the standard conversion, it's about $2 per DC watt to install a solar PV system. So if we remember, it's a 5 kilowatt system in direct current. So 5 kilowatts times 1,000 to get us to watts, because 1,000 watts is in 1 kilowatt. And then times, it's about $2 per DC kilowatt for installation. Okay, so it would cost us $10,000 to install this solar PV system on top of my roof. But as we saw, I would save almost $800 every year in electricity bills from having this system. So let's see how many years it would take to pay off this solar PV system with the amount of electricity savings that it would produce. All right, so it would take about 13 years to pay that off. And typically when you're looking at a project, you want to stay under 15 years. And solar panels are good for 15 to 20 years. So if I were to live in my house for the next 20 years, after 13 years, I would just be producing free electricity pretty much, because I've already paid off my panels, they're already installed. And as long as the sun is still hitting on top of my house, I'll still be producing electricity. And it's interesting when you think about sustainability, people look at it from both a financial standpoint. So what am I going to save? How am I going to save on my electricity bills? Or how can I make my site more resilient so that when the grid goes down, I can still have power, so that I don't lose any medication or spoil any food in my fridge. But you kind of have to look at sustainability from both standpoints. So if we were to keep burning fossil fuels and the world was to go on as usual, business as usual, at what point would we have to pay extra to create renewable energy when we run out of fossil fuels? Or at what point do we have to pay extra if our sea level continues to rise and our house gets flooded? So there's some costs down the road that you eventually may have to pay if you continue and climate change continues. So investing in sustainability today not only saves money from a utility standpoint, but it also helps the environment. So that's kind of the main takeaway that I want to give to you guys. There are ways to be sustainable as an individual. You can eat less meat and less cheese, and you can recycle and turn off the lights when you don't need them, and use less water. Be responsible about the amount of resources that you're consuming. But if you become an architect or an engineer or a construction manager, it's really important to think about how you're designing and implementing your building so that it benefits the environment around it rather than suck up resources from it. So that's the lesson today. If you have any questions, I am happy to answer them for you. Just reach out to ACE National and I'm sure they'll put you in touch with me. But it's been great teaching you about sustainability, and I hope you learned something today. Thanks so much.